Hello. I am going to be doing my last genre today, which my last genre is I'm going to explain what my transitions were and how my person, which is Aaron Rubik, relates to the topic of the American Dream. Which Aaron Rubik relates to the American Dream, even though he isn't from America. He had an idea, and he took that idea and he worked hard at it and he made it a reality. He came up with this puzzle, which is obviously the Rubik's Cube, and he took that idea and he made it a reality. He made it into something that people wanted to buy, and then he sold a lot of them. He sold over 350 million of just this. There's also other products such as the Quad Cube and the 2x2, which Quad Cube is just a different version of the 2x2, because the 2x2, it's just a bunch of 2x2 stacked on top of each other, which you can imagine the difficulty. And then there's just the simple 3x3, and there's others like 4x4, 5x5, and you can just look at my trading cards if you want to know more. But he created an idea, and then he worked to make it a reality, and that's the main point of it. Is if you have an idea, you can work at it and you can make it a reality, and that's what one aspect of the American Dream is. And so on to my transitions here. The transitions that I chose to use were the algorithms to how a Rubik's Cube actually is solved. And a Rubik's Cube is solved by using the algorithms. And if you don't know what an algorithm is just basically a mathematical sequence that you can use over and over and over again to make your desired outcome. So if I wanted to, I can just do right up. Well, obviously that won't get me anywhere. This is just going to scramble the cube, which we need to do this anyways. But another basic notation, which I should probably get into. If I'm talking about the right, I'm talking about this side of the cube. This is the right side. Whatever side is facing you is the front. This is the right, this is the left, this is up, and this is down. If I say that I'm going to move a piece right, that means that I'm going to move, let's say if I say right, I'm going to move the right side clockwise, which, to give you a better example, this is clockwise. If I say I'm going to use right inverted, that means I'm going to go right counterclockwise. I'm going to move it the opposite way. So it really doesn't matter. That's the same for every other thing. This is front inverted. This is up inverted. This is left inverted. This is down, leave. No, it is not. This is down. This is down inverted. And it's like that for every side. So, that's just some basic notation that's going to help you out later, because you're not going to know what I'm talking about if you don't know that. So, the first thing you need to do is you need to scramble the cube, which really isn't very important how you do that. You can do it more in depth if you want to, but I'm just going to quickly do this. So, this is what it'll come like in a package. Well, this isn't, because this is an older version. Newer ones will be much nicer. But this is what it'll look like roughly when you get it scrambled. It won't be probably the exact same, because there are over 43 quintillion different ways that you can actually scramble this, also including the solution, of course. But so what you need to do to first solve it with the algorithms, which I used as transitions, is what you need to do first is you need to pick the color that you want to do. It doesn't matter which color. Usually you can find one that's quite simple to do. Right now I think I kind of want to do orange. It already has two pieces here, even though they're not in the right spot. They're just there. So what you need to do first is what we're going to eventually need to do is we're going to need to get this orange side so that the orange cross is solved, so that all of these sides will be lined up with this orange side. So this, or rather, the white side will be lined up, the yellow side will be lined up, the blue side will be lined up with the orange, not the yellow. The green side will be lined up. So right now we have the orange and yellow piece and the orange and the green piece, which if you don't know this, of course you probably won't because it's different on yours if it's a newer one. On my cube, the yellow and the green are opposites. So if we were just to move this piece so that the orange and the yellow lined up, this would not be correct. This orange and the green will line up with the white. So what we want to do is we're just going to move this piece to the bottom. Doesn't matter how you do that, but we're going to leave this orange and yellow lined up, but simply move this orange and green piece to the bottom. And now what we're going to do is we're going to take this orange piece, and this is the green piece that we're going to move here, and we're going to just rotate it over so that it lines up with this green. Because now, here's the orange, and here's it lined up with the green. Now all we need to do is move it to the top, and now the orange and the green will be lined up while also keeping the orange and the yellow lined up. And you do that for all of the middle pieces so that we get this orange cross. So just for now we have the orange and the white. All we need to do is move it up, and then I'm hoping this will work out so I can tell you the first algorithm, but maybe it won't. Nope, it won't do it. But I'm going to make it do it just so we can kind of show you here. Okay, so this is going to be a situation that may arise, and you need to know this algorithm so that you can do this. Is right here we have the orange and the blue, and this is the orange and the blue piece, but it's not lined up right. The orange is on the bottom when it should be on the top. So what we're going to do is keeping the orange at the bottom like we did before, except for the fact that the blue will be on the bottom where we want the orange piece, is we're going to, with the blue side facing us and the orange on the top, what we're going to do is our first algorithm, which I'll put it on the screen so that you can actually see the algorithm while you're doing it, is we do front, up, left inverted, up inverted, and then we'll have it lined up. See, now we have the orange cross with all of these sides lined up. So now we are free to go in and we're going to put in these corner pieces. And to put in these corner pieces, what we're going to have to do is we're going to have to take them. We're going to have to find them first, obviously. Let's just pick a random one. Right here we have the orange, the green, and the white side, and the orange, the green, and the white piece. And what we're going to do is, since this is this place where we want to put this piece, it's already there but it's flipped around, what we're going to want to do is we're going to move it down, which doesn't matter. What we're going to have to do first is we're going to have to get it so this orange piece is on the right side of the cube of the corner that you want to put it in. That might sound a little bit confusing, but visual representation. Here's the piece, and here's the piece, and here's the place you want to put it. So what we're going to do is, with the green and the white side, since this is the orange, green, white, we're going to have the green facing forward, the white facing the right, and the orange on top. Doesn't matter, it just depends on the colors that you have, but we're going to have it so that this piece is in the bottom corner, the bottom right corner. And what we're going to do is we're going to do our first or second algorithm, however you want to look at it, and we're going to do right inverted, down inverted, right, down. And now what you'll see is now we have the orange, green, and white sides with the orange, green, and white piece in the right spot. So what we're going to do now with the rest, we're going to have to find the rest of the pieces, which here's this next scenario that we're going to need. Here is the orange, white, and yellow side. And the orange, yellow, and white piece is, instead of being on the right side like the last one, it is on the left side. And so what we can do, if we want to, if you wanted to, you could just go through and you can do right inverted, right down like 5 or 6 times until it gets up into the spot. Instead, what we can do as a shortcut is we can take the orange, the yellow, and the white side, and since it's the orange, yellow, and white piece, we can put it so that this corner, instead of being in the bottom right, is in the bottom left. And if we do that, we can just do the opposite, the basically inverse of the right inverted, right down, which will become left, down, left inverted, down inverted. And that will save you some time because now we have the orange, the white, and the yellow sides with the orange, the white, and the yellow piece in the right spot. So either way, whichever way you have to do it, if we have to do the right inverted, right down way, or we have to, hopefully this works out so that I can do this right. Yeah. Or if we want to do the left inverted, the left, down, left inverted, down inverted side. Either way, it's going to get you to the ultimate solution of having this side completed with this whole layer right. And so for time purposes, I'm just going to go through and solve that out using the right inverted, right down, and the left down, left inverted, down inverted. And so now, once you've done that, you'll have this entire first side solved, and unlike how you would traditionally solve it of just moving the pieces around, now we'll have this entire bottom layer solved with the pieces still matching up right here. And so then our next step is going to be, we have to go through and we have to fill in these pieces, these corner pieces, so that we have this entire second layer solved the same that we have the first layer solved. And so what we're going to do that is we're going to have to look at the top. The top is going to be the opposite color of the one that we're just solved. So with my cube, and it'll be like this on the newer cubes too, because the orange and red didn't change, it was just the white and the green and the yellow and the blue, I believe. Yeah, that sounds right. The opposite side of orange, the color we just solved, is going to be red. And so what we're going to do is we're going to look at the red side, and we're going to look to see these corner pieces right here. These are going to be the ones that we're going to look at. And right now we have 3 of them. Because if you look at this, this is the red and the green side, and the red and the green piece. That is going to be saved for later. That doesn't matter right now. But if you look, we have the blue and the yellow piece, the blue and the green piece, and the white and the yellow piece. And if you look for the other one is the green and the white piece. So what we're going to do, there will be 2 scenarios that this will happen. There will be one where you have to move it, whereas, here, let me just find one. Right here, we have the white and the yellow sides. And right here, we have the white and the yellow piece. And what we need to do is we need to move, since the white is on the top and the white is on the right side of the yellow, what we need to do is we need to move this piece right. And so what we're going to do is with the white side on the right of your cube and the yellow side facing you, with this piece opposite of the place you're trying to move it, so the white side, you're going to have it opposite where you want to move it. You're going to do this. You're going to do this next algorithm. You're going to do right, right, up inverted, right inverted, up inverted, front inverted, up, front. And now what you'll see is the yellow and the white side will have the yellow and the white piece in the right spot. And so now you can do that for the other ones if they so choose to work out like that. But as you'll see in many cases, like this one, there's the green and the blue piece, and the green and the blue piece, if you look, is not set up the same way. If you were to set it up with the blue side on the right and the green side facing you, the green is on the top. It's not in the right spot. If you were to do that, you're going to get one where this is going to be the green piece, and this is going to be the blue piece. It's going to be flipped. So what we can do is, instead of facing it opposite of the blue side, what we're going to do is we're going to move this so that it's opposite the green side, so that it's on the left. So you're going to put the green side on the left hand side of the cube. The blue side is going to be facing you because the green is on the top and the green's to the left. And so what we're going to do is basically the opposite of the one that we just did. The next algorithm, which is basically the inverse of the other algorithm, is with the blue facing you and the green on the right, with the green piece opposite, we're going to do left inverted, up, left, up, front, up inverted, front inverted. And now we have the green and the blue side with the green and the blue piece in the right spot. And so now all of the next scenarios that'll happen will have the exact same two things happen, where you need to have, like, this is what would have happened if we would have done it the wrong way. This would have been flipped. So now we just need to find the other pieces, which we have, like the blue and the yellow piece, the blue and the yellow side. And since the blue is on the top and the blue's on the left of the yellow, we're going to move it so that the blue piece is across from the blue. And then we're going to do, with the yellow facing us and the blue on the left side, we're going to do our algorithm. We're going to do left inverted, up, left, up, front, up inverted, front inverted, and then we'll have the piece in the right spot. We'll have the yellow and the blue piece with the yellow and the blue sides. And so now our last piece is messed up, and so we'll have to do, doesn't matter what you do, you can do either the left inverted up, left up, I forgot what I was doing. Okay. Yeah, you can do either the left inverted up, left up, front, up inverted, front inverted, or you can do the opposite one, which I'm not going to say that out because it's becoming repetitive. But now that we have this out, we have it so that the white is on the top. It says the white is on the, and I don't want it there, but I'm going to have to do it. The white is on the top, and the green is on the, or the white is on the left, the green is on the right. And so the white being on top, we're going to have to move it across from the white. White, green, white across. We're going to do our left inverted, up, left, up, front, up inverted, front inverted. And if it works out more where the right side one, like if the green, this was the green side, this is the white side, and the green was on the top, if it gets to be more like that, just go back and read that. Right, up inverted, right inverted, up inverted, front inverted, up, front algorithm, which I know that's a lot to take in, that's a lot of words, but just go back and look at that part of the video because that'll help you. So now that what we do is, since we have both these layers solved and this side is still solved, now what we need to do is, funny how that works out, but that's not correct. What we need to do is we need to find this cross like we did before. We need to find the red cross, which obviously we already have it, but it's not correct. What we need to do is we need to get that so that they're lined up with the correct sides like they were. And you'll have 4 different scenarios that this will happen. Either it'll be like this, where the cross is already made, there'll just be a dot, there'll be a triangle, or not a triangle, an L, backwards L, like this, like what I'm making, or there'll be a line. In our case, we already have the cross, so this saves us time, but I'm just going to screw this up just so that we can, for all intents and purposes of showing how to do this. Right here, we have the backwards L. Now, with the backwards L, this is basically going to show us everything but just the single dot, which I could show, but I'll just do picture-in-picture of all the different scenarios. So, with this one, what we need to do is, with the backwards L, we're going to have this part of the L, which would be this way generally. We're going to have it on our left side. And then the top part of the L is going to be pointing out from us. So it's going to be pointing this way towards the wall. And so what we're going to do is we're going to do our next algorithm, which is going to be front, right, up, right inverted, front inverted, or not front, up inverted, front inverted. And now what we'll have is we're going to have our line scenario, which our line scenario means that if we do this one more time, we're going to have our cross. And so what we're going to do is we're going to do front, right, up, right inverted, up inverted, front inverted, and now we have our cross. It's not necessarily made so that it's actually lining up, but we have our cross, and that's where we want to start. So now what we need to do is we need to line these up. And so what you're going to do is there will be different scenarios. There will be like what we're going to have now, where we have two of the colors will be right. Right here we have the red, the blue, and the yellow side, and we have the red and the blue is lined up, and the red and the yellow is lined up. But if you look over here, the red and the white and the red and the green are not lined up. So what we're going to need to do is we're going to need to take this yellow, and since it's farthest to the left, basically, is we're going to put the yellow facing towards the wall that way. And we're going to have the blue on the right. And so what we're going to do with the blue on the right and the yellow on the back side is we're going to do the next algorithm. And the next algorithm is right, up, right inverted, up, right, up twice, and right inverted again. And now what we can do is one more up will get us to all of these sides will be correct. Now the other scenario that will happen there is that let's pretend that this blue and this white side were lined up and these yellow and greens were not lined up. Then all you have to do is with this side facing you, the blue side facing you, and the white side, and it doesn't matter, it just one of them has to be facing you, one of them has to be facing away from you. Do the algorithm, and then it'll go to where there will be two sides correct, and then you just put one away from you and one on the side, and then do that, and then it'll come out as the right way. And so now that we have our cross, and our cross is all correct, now all we have to do is find the pieces. And our corner pieces are all correct right now, which I don't like how that happened because I'm trying to show you how to do this, and it's just not gonna let me. It wants this to be done. But now that I've messed it up, now the corner pieces aren't correct. Generally, one of them will at least be correct. Like right here, we have the red, green, and blue side, and the red, green, and blue piece. And although that's not put up into this side, that is correct. That is in the right spot, so we're on track. But if it doesn't work out that there's a piece that's correct, just do the algorithm that I'm about to tell you from anywhere on the cube, and one of them will be correct, and then the next time you do it, it'll be right. But once you get it to here, you will never have to do it more than twice. This next algorithm, which this one is a little bit more tricky, is going to be with the piece that you want to solve correctly in the bottom right corner. It's going to be up, right, up inverted, left inverted, up, right inverted, up inverted, left. And now what you'll see is, even though it didn't happen, this will still be right. And now if we do it again, we're going to do up, right, up inverted, left inverted, up, right inverted, up inverted, left. Now all of them will be correct. And now you can see one of them is already up there. This is in the right spot, this is in the right spot, and this is in the right spot. So now we have our last and final thing that we need to do. And it's going to be the exact same algorithm as at the beginning, it's either going to be right inverted, right down, which in our case it's not. Ours is going to be the left down, left inverted, down inverted. Just to save time, you could do right inverted, right down if you wanted to, with this in the bottom right corner. But to save us time, what we're going to do is, since it's on the left side, this piece right here is on the left side, what we're going to do is with this piece in the bottom left corner from where we're solving, what we're going to do is we're going to do our algorithm, which is left, down, left inverted, down inverted, and we're going to repeat that process. And then what will happen is this side will become solved. Now, this will look like it got messed up. That's okay, because that's supposed to happen. So now, instead of don't rotate the cube. If you rotate the cube, things are going to get screwed up. You want to keep the same side that you were using before. And all you're going to do is you're going to rotate the top so that the top, this piece, will be in the bottom left corner, the same as it was before. And then you're going to do your algorithm, which is either right inverted, right down, or in our case, left, down, left inverted, down inverted. And you're going to repeat this process until we have this next piece solved. So now all we need is one more piece, but you don't want to rotate the cube, you want to rotate the top. And then we're just going to do it one more time. It's either going to be right inverted, right down, or in our case, left, down, left inverted, down inverted, and then repeat that. And now what you'll see is the cube solve itself, or rather you solve it. But what we're going to do now is, well, what I'm going to do now is I'm going to just show you what it looks like when you get familiar enough with the cube. Because I've been doing this for probably about a year, probably more than that, about 2 years or so. I've been able to solve one of these, and I can also solve these two, just because once you know how to solve this 2x2, you can solve this. It's just a little bit more tedious. So once you become acquainted with the Rubik's Cube and you understand how it works, you're going to be able to move it faster. Which, some Rubik's Cubes get a little bit messed up inside and it's a lot harder to move them. But with mine, I put Vaseline in them just to make it move a little bit faster. But what you'll notice is the pieces will pop out a little bit easier if you do that. And with the newer ones, it's harder to pop the pieces out. Like, I can just pop this piece out. Or not. I can't pop that one out. But I don't really want to pop them out. But it's a lot easier to pop mine out than it would be the newer ones. So what you're going to do, or what I'm going to do, is I'm just going to show you what it looks like when you get a little bit more acquainted with how the Rubik's Cube actually works. And how the algorithms, and eventually you'll get to the point where you don't even think about the algorithms. They just happen. You just do them instantaneously in your mind without even thinking about them, because you don't need to. And I just put that in the wrong spot. That didn't need to be moved. I wanted to put that there. And eventually, if you really want to work at it, what you can do is you can try to move it. You can try to speed cube, as they call it apparently, and you can try to challenge that world record in about 7.7 seconds. I think it is. I think it's 7.76 seconds or something by a guy from Germany. And I am nowhere even close to doing that because that guy is insane. Or, if you want to, you can try to do the guy juggling 3 Rubik's Cubes and solving it while he juggles it, but that might be even harder than trying to solve it in 7 seconds. I'm not gonna lie. Oops, I didn't need to do that. And there you go. And then you'll be able to solve it. That was probably about 3 minutes or so, I don't know. That wasn't very fast, but we're not going for speed here, we're going for a tutorial. And so that's how you solve the Rubik's Cube. That is the transitions that I use, the algorithms, which if you want to know more about them, you can just go back in this video, or if you probably look up, if you're going to look up a video, I would suggest Dan Brown's video, I believe is his name. That's the best video, I think, of how to actually solve these things, because he is insane. Because he just moves it with his fingers. He goes like this. And his cube, he can just move his cube. Ridiculous. But that's how you solve a Rubik's Cube. Erno Rubik relates to the American dream because he created an idea, and he made it a reality. And I hope you enjoyed my video.